In this video, we're going to talk about how to find the exact values of cosine 2 pi over 3, sine 2 pi over 3, and tangent 2 pi over 3. And in general, the strategy we're going to discuss will work, of course, for any angle that you find on the unit circle, any point corresponding to an angle. So the particular angle that we're looking at is 2 pi over 3. So if you want to, you can go ahead as your first step and locate 2 pi over 3 on the unit circle. Same thing as 120 degrees, and just kind of circle it, noting that we have a point with an x value and a y value, the x value being negative 1/2, the y value being the square root of 3 over 2. So now let's talk about how to get the answers. You can see written in blue on the left-hand side of your screen that anytime we're looking at something on the unit circle, cosine of theta, whatever it is just going to be the x value of the point that corresponds with that angle measure, whatever it may be. The sine of theta is just going to be the y value of the point that corresponds with that angle, and tangent is going to be the y value divided by the x value. Now that of course comes from the fact that tangent theta is the same thing as sine theta over cosine theta, so i.e. y value over x value. So that's a good way to kind of connect all of those ideas in your mind and help you memorize what's going on with these trig functions and how it ties to the unit circle. So now let's discuss what to do for this particular problem. So our theta in this case, of course, is 2 pi over 3. We've already circled it, 2 pi over 3 radians, and we have a point that corresponds with it. We already mentioned negative 1/2 square root of 3 over 2. So for cosine theta, all we have to do is take the x value there. So the x value is going to be negative 1/2, and we don't have to say theta. We know this is cosine of 2 pi over 3. And that's just going to be equal to the x value, and that's all you have to do. You don't have to do anything fancy. You can just pick the x value for any angle you find on the unit circle, and that's going to be the value of cosine of that angle. So for the sine, we're going to do the same thing. Sine of 2 pi over 3. This time we're just going to take the y value because that's how sine is defined. So the y value is the square root of 3 over 2. And that's it. Again, nothing fancy. It's just interpreting the information and knowing how to use it, knowing what comes from where. So the last thing we need to determine for this particular problem is the tangent of 2 pi over 3. And that's just going to be our y value divided by our x value. So our y value is the square root of 3 over 2. And the x value is negative 1/2. As already stated. Now for this particular problem, we can do some stuff to make it look nicer. We can do some algebra to simplify this fraction over a fraction. So anytime you're dividing fractions, that's the same thing as multiplying by the reciprocal of the denominator. So really this is the same thing as the square root of 3 over 2 multiplied by negative 2 over 1. And of course the 2 on top and bottom, since we're multiplying the fractions, is going to cancel out. That's going to leave us with negative square root of 3 over 1, which is just the same thing as the negative square root of 3. And so those are our answers, negative 1/2 square root of 3 over 2 and negative square root of 3 for the cosine, the sine, and the tangent of 2 pi over 3 respectively. Now I did want to talk just for a brief moment, since this is a very long video, about why this is the case, why we can just take the x value for cosine of theta or the y value for sine of theta. And the answer for that comes from the fact that if we were to draw a triangle using this point, 2 pi over 3, and we're going to use what of the x-axis we have, and our hypotenuse, of course, is right here. So we have a right triangle, and we're going to call this theta. Really, it's the same thing as calling that theta in standard position, but it doesn't really matter. If we were interested in finding, for instance, the cosine of this 2 pi over 3, of this angle, theta in this triangle, then we would do the adjacent over the hypotenuse. So notice the adjacent is going to be the x value. It's how far we move to the left on the x-axis, so that's the x value, negative 1/2. The hypotenuse is always going to be equal to 1 on the unit circle though, and that's why this works. It is the unit circle, so literally all of the radii, which are all of these things right here, are all equal to 1 because it's the unit circle. So therefore, that's why we can just pick the x value for some cosine theta, or the y value for sine theta, or tangent theta is just the y over the x, because we're talking about the unit circle where the hypotenuse is equal to 1. And that's why what you see written in blue only works in that capacity. So again, it's not too bad to do. Just practice with some of these. Your x value is always cosine, your y value is always sine on the unit circle, and that's all you have to know.